See, that's the problem. Some teachers become teachers because they know it really well, but it doesn't mean they should be teachers. All right.
That's why she got money. Makes better money, not teaching.
Okay. Oh yeah. Well, you definitely don't go into teaching for the money. I want to make a lot of money. I'm working hard to become a teacher. Oh, okay. You got problems. You're gonna be disappointed. You're gonna be disappointed. You're gonna have a bad time. All right. So any specific questions from homework stuff? I heard a possibility. I turned that on, right? Please don't. Okay. Don't make me have to work my way over there again. Yes?
So it's a fraction, and then it has to do
Oh. So if I put anything inside here, how would I work it out? Yeah, I would write it twice. So if it was 17 squared and I was making you do it by hand, you would do 17 times 17, right? So if I said 2/7 squared, you would do 2/7 times 2/7. Yeah. So exponents never mean anything else other than that's how many multiplications you have, right? That's all it could ever mean. I could put different stuff inside there, but all it ever means is you got this many of these, multiply. That's all it could ever mean. All right, cool. I like it. Okay. Anything else from homework stuff? Okay. All right. So we're gonna pick up where we left off last time. Then I think last time we didn't quite get into decimal equations yet, right? The last thing we did was, well, actually we multiplied and divided too. Oh yeah, and then we added subtracted. That's right. So let's just do a couple of quick warm-up questions. You guys, decimals, exactly. So do these problems for me. Let's see. Now, hopefully it's pretty obvious. Hopefully it's pretty obvious I'm asking you to do these by hand. This is not a how do I use my calculator class, right? Yay, press buttons. Some people will actually still fail that class because we're not sure how to input things into a calculator correctly, but this is to be done by hand. You can check it with a calculator, sure. I'm gonna have you help me go through it. Is it right? So I don't know if you remember the main thing was subtraction. And then we talked about multiplication and what happens with the decimal square. Yeah, but how many places? How many places would this go? It has to go to the left. Multiply, correct how many places you gotta go back, right? You have to go back. Yeah, so it's like you multiply 112 times 3, but the not even decimals. But then your answer is still go back. Places. Subtraction that you can align up. You can align up. subtractive lines. And then division. You can see a nice hole that you're dividing with. I think they're doing Spanish, I think. Sounds like I think she's got the yelling approach of teaching.
Oh, no Spanish.
You know Spanish. Oh, it's got evil on number 3. You can round it to the hundredths place, I think. You understand what I mean?
No.
Whatever the answer is. If you need to. Round to the hundredths place. Or if there's a pattern to it, you can just put a line over what's the pattern for. There might be a pattern to that one. All right. Yeah, what's up? You know it's easy? Oh, she knows she's teaching. What is she teaching? Can I jump up? Can I jump on her? Oh yeah, yeah. That's what I think. You don't have to do that. Careful. All you do is just multiply it like there's no decimals. Yes, sir.
No, the decimals have to be lined up.
If you subtract your at.
If you subtract your add, they'll probably multiply.
Nope. It's very, guys, adding, subtracting. Do you start to realize that it is always the more restrictive thing? It needs like terms. You have to have like denominators. The decimals have to be lined up because it lines up the like terms when you line the decimals up. Multiplication, much less strict, much more relaxed. Here, I multiply as if it was 112 times 3. And then I'm going to move the decimal back to total number of places, right? So I do 3 times 112, which would be what? 336. And then I'm going to move the decimal back. 1, 2, 3. 1, 2, 3. So it'll be 0.336. Yes, ma'am.
Is it okay not to put a 0? I put.
Yeah, it's okay. We just do it so that we don't lose that decimal. You know, it's easy to lose him. Poor little dude.
Okay.
And again, this is 112 divided by 10. Oh shit, are you guys cool with that? 11.2 is 112 divided by 10. Do you guys see that? Because what happens when you divide by 10? Okay. What happens when you divide by 10? The decimal goes?
The decimal, right?
Yes? It goes back once, right? When you divide by 10. In fact, what is 40 divided by 10? So you move the decimal back once. You just never thought about it like that, but that's what happens when you divide by 10. Why does it work that way? Because decimals are based on 10. So when you work with the number 10 on decimals, it just moves a decimal around because that's what they're based on. So that's the same as this. 0.03 is 3 over Tenths?
Minor.
Hundredths. So what I'm doing is I'm doing 112 times 3, which is 336, and then I got to divide it by 1,000. You guys see that? Because what's 10 times 100? 1,000. When I divide by 1,000, I go back 3 places. Now again, please, dear God, do you understand that? Please don't do it like this. I'm trying to explain to you why this works the way it does. It is 112 times 3, divided by a bunch of tens. So that's why if I collect 1, 2, 3 total decimal places, my answer has to go back 1, 2, 3 decimal places. Because then I'm doing this division. So it's like dividing at the end. Maybe. No, not at all. All right, let's do a real quick little side problem. 0.2 times 0.5. What's 0.2 as a fraction? 2 tenths. What's 0.5 as a fraction? 5 tenths. So when I do 0.2 times 0.5, I'm actually doing 2 times 5
Over 10.
over 100. And this would be 0.10, right? 10 hundredths. So isn't it the same thing as saying 2 times 5 is 10, move it back 1, 2. Same answer. Because this move it back, I'm doing that after I multiply, which is exactly what we would do if we looked at it as fractions. Yes, ma'am?
Isn't it multiplication, you just count how many are 100 decimal?
Yes, I'm trying to explain why that's true.
Oh.
I mean, you can just leave 1, 2, 3, 1, 2, 3,
Yeah.
done.
Yeah.
But I'm explaining why it works.
Oh.
Yeah. So please, dear God, again, I'm desperately trying to make it really clear when I'm not showing you a way to do the problem. I'm showing you why the way we do it works. So how do you do this? 2 times 5 is 10. Move it back once, twice, done with it. Why does that work? Because of this. I'm looking at the tops. 2 times 5 is 10. And then I'm moving it back once. So back twice total. Maybe. If you don't understand exactly why it works, at least be able to apply it. Understanding why it works would be the best place for you to be. But at least be able to do it. Let's do one more of these. What about if I had 0.0491 times 123.15? Yeah, I like it. It's gross. It's gross. So I got 123.15 times 0.491. What happened? I just wanted to write it like that because that's the smaller number. I'm going to put that second. It's easier to look at.
No.
Not when you multiply. Not when you multiply, right? Only when you subtract and add, because we'll talk about subtraction just in a minute. All right, so let's see. You get 5, 1, 3, 2, 1. It's just 1, so you get all the same numbers. Is that cool?
Yeah.
And then 0. Now I get 9. Oh shit. 5, 4, 13, 1, 28, 2, 22, 11. Is that? How's that? Double check me. You never know this time of day.
Sure.
And you're not like, whatever, man. 0, 0. Let me take all these away now. 20. So 2, 6, 2, 1, 9, 4. Shit. So then we got 5, 6, 6, 6, 1, 2, 4, 0, 1, 2, 6. All right. So, I mean, if the problem would have been 1231.5 times 491, my first step would have been get here. It would have been the exact same digits. What would have been different is the number of decimal places I can go back. Here, how many places do I have to go back? 1, 2, 3, 4, 5. How many total decimal places are there? 2 and 3. There's 5 total decimal places. So I take the decimal back. 1, 2, 3, 4, 5. Bam. What's 0.491 really close to? 0.5, right? What's 0.5 better known as? Half. That's about 120. What's half of 120? Holy shit. So again, estimation is a really powerful thing to be able to do because it tells you if it looks like you're right. If I said an answer was a 604, I go, I can't be right. Half of 128, 604. All right, so let me even do one more thing. So we just did the 0.2 times, let's do 0.2 times 0.4, just because. That would be 8, and I would move it back once, twice, right? So it'd be 0.08. So if I did 0.02 times 0.4, it's still going to be freaking 8, right? That's why I don't have to move the decimals. That's why I don't have to line them up. It's still fundamentally some kind of 8. It's just going to be a smaller kind of 8. Does that make sense what I mean when I say that? It's not technically correct what I just said, but I don't really care. It's going to be a smaller answer because I have a smaller number here. So it's still going to be 8. But I'm going to move it back 1, 2, 3. 1, 2, 3. So 0.008 instead of 0.08. So it's really just a multiplication problem, and then it's got one extra added step. Just count how far back you take the decimal. That's decimal multiplication. That's all it is. Okay, cool. I like it. So what about this poor little problem here? What am I missing there that I want to add in? Good. And also, just to make sure you guys really get, when I line these decimal places up, I am lining up like terms. Can I do 1/10 minus 8/10? Yes, because they both have the same denominator. Do you see how that's the 1/10? And that's the 8/10. So if I line up the decimals, all my like terms automatically line up. What is this? This is 5. You can do it. Tenths. That's 5 thousandths. This is 6 thousandths. I can put those together. They line up. Like terms line up when I line up the decimals. Do I need like terms when I multiply? What's 1/10 times 200ths? Are they like terms? Do they have like denominators? No. Why do I not give a shit? Because I'm multiplying. 1 times 2 is 2. 10 times 100 is 1,000. So that's why multiplication of decimals, you don't need to line the decimals up. They don't have to be like terms. Addition, subtraction, oh shit. They must be like terms, we know that. Alright, so how do I do this then? What are you doing over there?
Borrow.
Borrow, I gotta borrow, just like real life. So I need to have 4, 10. I need to borrow from him, but he's got nothing for me. So I gotta borrow from him to make him 11, right? And then I have to borrow from him to make him 10, so this will become 10. And then I got everything. I gotta borrow from him now to make him 14. Good Lord, it's a lot of borrowing. So now I can just go 10 minus 1, 9, 14 minus 6, 8, 9 minus 7, 2, 10 minus 8, 2, 3 minus 2, 1.
I didn't do the same work, but I got the same.
Neato. So you might have done a different order of your borrowing, but that's fine. Oh, you guys probably learned to make this 0 become a 9 and then automatically borrow. Yeah, sure. It's the same thing I just did. I like it. Well, do it your way, fine. It's really the same as mine, you just don't show all the steps. Alright, so let subtraction and addition be relatively easy. Why did I have to add that 0? So that I have something to work with. I can't subtract 1 from the void, right? the void. It's not even 0. Alright, so how do I do this? So I can set it up, and then you guys kind of do this by memory. But I explained to you why this works the way it does. If you move this over twice, and that really just equates to multiplying top and bottom by 100, that would move it over twice. Because it is a fraction. I can do the same thing to the top and bottom. That's why that works. And now you just divide like always. 6 goes into 14. Twice, it's great. 6 goes into 22. 3. 6 goes into 49. 8. What do I have to put here? Decimal 0, right? So now I can bring down the 0. 6 goes into 10. Once. Bring down another 0. 6 goes into 40. 6. And now you see that it's going to be repeating, don't you? So you can either round it to the nearest hundredths, or instead of it was repeating, you can just put a bar over it. Sorry. Got a silly song in my head. If it goes on, then you should have put a bar on it. Alright. Okay, that's cool. So that's kind of a review of everything we've done recently. So now let's get into solving equations with decimals. Yay! And actually, let me show you. Well, let's see. Let me show you this one. Let's see if you can see. Let me just show you. You could right now just start working directly with the decimals. But let me show you kind of a smart thing to do. What did we do here? We multiplied both sides, the top side and the bottom side, by 100. So I had a nice whole number to work with, right?
Right.
So I can multiply both sides of this by what? How many times do I want to move the decimal over so there are no decimals? Once. Once there, once there, once there. You see that?
Yeah.
So if I multiply both sides by 10, all the decimals will move over once. Multiply by 10. So now this becomes x. That becomes 4. That becomes 12. All right, let me stop there. You guys got even more quiet. Any equation that exists anywhere, I can multiply both sides by anything except 0. When I multiply, and let me go back to this idea. If I multiply 100 times 0.0047, you should not need a calculator. You should not need to line this up and multiply it out. You shouldn't need any of that shit. What does multiply by 100 do? Moves it twice. Good. So my original problem had these stupid decimals in there. I don't like decimals. If I don't have to use them, I'm not going to use them because they can make me make mistakes easy, right? So one thing you can do is, if you notice all your decimals have one place, multiply everything by 10. Because what that does is it moves the decimal over once. Just like multiplying by 100 makes it move over twice, multiply by 10 makes it move over once. How are we doing there? Is that no good? That's no good. You're all at least looking at me, but you're looking at me in really perplexed ways. So solving this, x is 16. Yay! Say again? So again. I can, how would you solve this equation here? Multiply both sides by 2. That's the smart number to multiply both sides by. If I wanted to, Is there anything that says I'm not allowed to multiply both sides by 5? I could do that all day. Would that help me?
No.
No, it would not help me. Because then I'd have 5x over 2 equals 35. Good job, Jeff. So I'm going to multiply by the thing that will get rid of what makes this ugly. In fact, I'm going to multiply by the thing that makes me solve this, get x by itself. So then I multiply by 2, so I get x is 14. Here, there's a 0.1. I want that to be a full 1. What do I multiply by to make it a full 1? I multiply by 10. Yes, ma'am.
Are you allowed to do that? Like, how do you know if you're allowed to do that?
Allowed to do what?
Like, just change it instead of like decimal. Let it be like a phone number. And just multiply.
How did I change it?
No, but I mean, like, how do you know if you have to change it?
Okay.
Like, in the problem that we do, solve, and I just multiply it by 10 and we get a full number and then end up with 9.
Let me, maybe this will help. I like it. So how many places do you wish you could move every number into? Twice. Because why would that be good?
They would get rid of the...
There would be no more decimals. Thank God this lives in an equation where I am allowed to multiply both sides by any damn thing I want to. So what? Let me stop right there. Is everybody cool with what I just said? You have to be, because we've been doing that forever. I can do anything to one side of an equation as long as they do the same damn thing to the other side. That's the whole idea of solving equations. Right? If I have x plus 4 equals 7, I'm going to subtract 4. If I have 4 times x equals 7, I'm going to divide by 4. I'm going to do the opposite, but I must do it to both sides. Is that cool? Is that all right?
Make it legal people.
How many of you can do like this? Can you do like this if you could do like this? Some of you can't. I'm sorry. You weren't born with that. So when you agree, if you can't do this, then can you like go like that or something? Oh God, some of you guys like to shut up. Alright, gotta work. So tell me where I lose you. If I have an equation, I can multiply or divide both sides of it by anything except 0. That's a true statement. Are you guys cool with that? We've done that before, right? If I have the equation 14x equals 28, how do I solve it? Divide by 14, right? Why am I allowed to do that? Don't tell me because there's a 14 there. It doesn't tell me why I'm allowed to do it.
Because 14 can't go into 28? No. You want...
Because it's the equal sign.
Because there's an equal. It's an equation. If I do the same thing to both sides, it maintains the balance. That is the main idea of solving equations. As long as I do the same thing to both sides, it's valid. It's legal. So I can divide both sides by anything I want to, but what's the smart number to use? 14. Because then I get the answer.
Use a dumb number then. Use just an unequal number.
Alright? Well, alright. Now watch. I can divide both sides by 7. Alright, y'all sure? I can divide both sides by 29. That is still a true statement. Did it help me at all? No.
You didn't get it.
Do you see what I mean? I don't know what you expected to happen dividing by 20. If it doesn't go into either of the things, you can't reduce it. This is still a true statement. This is still true. The answer is still 2. What's 14 times 2? 28. So 14x over 29 is 28 over 29 if x is 2. It's still a valid equation. I just did something that didn't make it any easier to work with.
Right.
But I could do that if I really felt like it. Do you see what I mean? So there's a question of what are you allowed to do? And then there's a question of what would make sense to do. So are you allowed, if you feel really sick, are you allowed to go outside and run a marathon?
Yeah.
You're totally allowed to. There's no policeman's gonna, you look like you're sick. I gotta take you in. No.
But you're an idiot.
Is it a smart thing to do?
Yeah.
No. Right? I don't care how much you think you're running it out of your body. No. You're not in a good place. You guys with me? So there's math things that are legal. And then there's math things that are legal that are smart. Two separate things. I like it. So, I am allowed to multiply both sides of this by 3. I can multiply both sides of it by the square root of 11. I could divide both sides of it by 18 billion. All those things are legal. It wouldn't make the equation any less true. But what's the smart thing to multiply both sides by? 100. Why 100? Because it's going to make all the decimals. It's going to make all the numbers become whole numbers. So if I multiply both sides by 100, so what I normally do actually is I just put it next to everything.
So you're saying wherever the decimal is at, multiplied by that?
No.
You're not saying.
We'll do another problem. I'll show you what I mean. I'm making these nice and easy for right now. Hold on. Guys, you don't get a choice. Whatever you do to one side, you must do to the other side. I like it.
It's like you already have the answer, you're just trying to find like,
So what do you get here?
why it gets that.
Yeah. 7x minus 35, 14. So does that look better than it did? So I chose a smart thing to multiply by. Now you just solve this like always. So how do you solve this? At 35?
And then we just put 49. And then divide.
Divide by 7.